Hey, hi everyone. Today we are going to learn about statistics. We'll see how statistics can help us to make better decisions. Statistics is at the core of data analysis. Without knowing statistics, we can't do data analysis. Having strong understanding about statistics help you across industries. Statistics is getting used in sports, it is getting used in politics, it is getting used in marketing, it is getting used in finance, operation, policy making, healthcare. It is getting used across various domains. You name it. There is a beautiful movie called Moneyball. It shows how statistics can be useful in sports also. Okay, so whatever example we will see here, all those will be applied. People are who are working in industry, they are working on those problems. Okay, so this is Financial Times article where Cliff Asness says that AI is just a statistics, and I agree with him. Cliff Asness is hedge fund manager and the co-founder of AQR Capital Management. Prior to that, he was working with Goldman Sachs. He has a lot of paper on his investment philosophy. You should read it. We will talk about that later, how you can get those papers and what exactly these people are working on. Okay, this is another article from Financial Times. I have given link in resources. I highly recommend you to read that. AQR is applied quantitative research, exploits long term market inefficiencies and behavioral glitches. They deploy billions of dollars in these strategies. Keep in mind, none of this is investment advice. You should learn about these things and get a good job, get an experience, and then try something on your own, or become CEO of firm if you become better at what you're doing. Whatever we are discussing are getting used in industry to solve business problems. We'll not look at Titanic or Irish flower dataset, which are typically used while teaching this concept. Whatever we will look at will be real world problems, and I want you to get inspiration from these case studies and apply uh, principles in your domain. Okay, so what kind of business decision uh, we can make using statistics? Okay, so here are few examples. The first one, does spending an additional dollar on marketing expenditure adds to gross profit or not? Let's say you're working as chief marketing officer at startup and you want to understand if you spend 1 million on particular campaign, what impact it will have on sales, right? uh, so this is marketing mix problem. Okay, second problem is related to econometrics. Let's say you're working with government and you want to understand if you roll out particular policy, what impact it will have on GDP, right? um, in India, government roll out demonetization policy, and prior to rolling out those policy, government do analyze the impact of those policy. So let's say you want to understand the impact of policy on GDP, right? So this kind of typical regression equation you will have, policy implemented or not, right? If implemented, 1, otherwise 0, right? Let's take some numbers. So this is 2, then 0.3 into, if implemented then 1, otherwise no, right? So your base GDP is 2 trillion. If you don't implement policy, then the GDP is 2 trillion. The moment you implement policy, which is 1, it is adding 300 billion to the economy, right? And this kind of models you can see before implementing those policy, and this is very useful, right? Then the third is factor modeling. Okay, uh, if you want to understand the factors which are driving your returns, you can build factor models. Okay, a lot of fund managers were looking at COVID factor uh, when corona happened. So what they did is that which companies are having major customer base out of China. If yes, then how do they hedge that COVID factor risk, right? They were looking at that. um, Typically in finance, um, three factor FEMA French model, five factor FEMA French model are very well known. So in three factor model, what they look at, whenever you invest in small companies, it tends to have higher excess return, and if you want to understand that, you will run the uh, SMB factor. If you regress your returns against that, then you want to understand the stock is value stock or growth stock, then their HMB factor is there. And and then there is a one factor related to market, which will show you, let's say you invest into emerging market like India, you will get higher return. Why? Because by investing in emerging market, you are exposed to certain amount of risk, and because of that you are getting higher return. But if you invest in developed market, you might not get that premium, right? So yeah, these kind of factor models are getting used in industry. But what I want to highlight, one thing is that before building this model, one should have um, fair understanding about your domain. Then only you will understand what problem you are trying to solve. Okay. um, Understanding cause and effect is very critical in business decision making. Correlation does not mean causation, and that's where your domain knowledge comes into picture, and that's where machine cannot do everything. uh, it needs human judgment. So the last one, uh, this is very interesting. Okay, uh, we talked about correlation does not mean causation, right? uh, and in your domain, if you find variable like this, you should be able to understand this phenomenon, right? So let's say you are elementary teacher and you find out that reading is an important skill. Elementary teacher have observed that reading ability of their students tend to increase with their shoe size, right? The student who are spending time in school, um, they are practicing reading, and the students who are not, they will not increase their reading ability, and shoe size will increase with their age. So if you build model around this kind of variables, it will not yield any result, right? um, so understanding cause and effect is really important. Okay. Before starting the session, I would like to share uh, one story with you. It's called Toothpaste Factory Problem. This was first shared by Terence. Uh, so, so what happened is that the toothpaste factory sometimes shipped empty boxes without the tube inside. The CEO of toothpaste factory got top people in the company together, and they decided to start a new project to solve their empty box problem. Budget was allocated, and they have given 6 month time. Budget was around 8 million, and they had a fantastic solution, on time, on budget, high quality solution. Everyone was happy. um, it was successful project. They solved the problem by using high-tech precision scale that would sound a bell and flash a light whenever a toothpaste box would weigh less than it should. Okay. While later CEO was analyzing result, it turned out that the number of defect picked up by the scale was zero. After 3 weeks of production use, it should have been picking at least a dozen a day, right? Then CEO travel down to the factory and walks up to the assembly line where this precision scale was installed. Uh, a feet before the scale was an inexpensive desk fan blowing the empty boxes out of build into the bin, and the guy who was responsible for uh, picking those boxes when bell rang, he was tired of walking again and again there, and he put that fan there, and it would have solved the problem earlier also, right? and and in the story like this, you can learn that just because you know analytics, there is no need to spend $8 million and deploy fancy solutions, fancy analytical solutions. Rather than that, they could have like installed those fans there and it would have solved their problem, right? So one should use common sense also. Is there really need of analytical solution? um, if yes, then you should go ahead with it, right? Okay, so earlier we talked about factor model. Okay, so this is very good research paper by AQR on factor investing. uh, you should read about it. This is the link for the paper. Okay, and there is one book for practitioner on factor investing. A lot of people who contributed are currently working with Goldman Sachs. You should read this book if you are someone who is interested in finance. Okay, then how you can develop those models, right? There are a lot of open source libraries, okay, which will help us to build those model. We'll see um, how we can use that. All the tools which we will use for building these models in the courses, all those are open source. And this is very interesting article by Frank, who is professor at Harvard Business Schools. He says that firm would pay an estimated 3.5 times more to build software and platform if there is no open source software, right? Let's say you want to build regression model, and you can simply use open source libraries like stats model, right, which are there, rather than writing code for regression from scratch, which will uh, like be time consuming and you will spend money also. So we'll see how we can do that. Okay, so this is very beautiful library on GitHub called Riskfolio Lib. Okay, let's say you invest in emerging countries and the returns which you are getting, and you want to analyze the risk, right? And you want to break those risk, right, from where exactly it's coming. Is it because of that particular market? And you also want to analyze returns, right? You can use these open source libraries. I have shared, like, in next slide there is one notebook also, you can have a look at that. Okay, I have shared link also. If you want to understand risk in better manner, you should read BlackRock's guide to fixed income risk management book. They have shared a lot of things there. They use something called EHR, which is very specific to BlackRock. In this library, you will see how practitioners are using VAR or expected shortfall to analyze the risk of their portfolio. And this is the notebook. Okay, these are the various factors. Okay, size, quality, momentum, value. Okay, perfect. Then we'll talk about how we can use analytics in marketing. So typically you build marketing mix model which helps marketer to compare different investment. You want to understand what is driving your sales, you can do that, right? uh, and then once you do that, How do you optimize marketing budget allocation for future? We'll talk about that also. Okay. uh, Before moving ahead, I want to share uh, the product details, which is by Google. Google launched Meridian, which is open source. This is Meridian. Okay, so Meridian, it's open source marketing mix modeling tool. Meridian is highly customizable modeling framework that is based on Bayesian causal inference. We'll talk about that later. Okay, and we'll go through the data and the strategies. We'll see the code, how we can implement that. Whenever you implement any strategies based on any model, you should understand what is behind the model. You should not simply use the model as it is. The reason is that people who know all these things can get better job and improve companies efficiency and performance, and the people who not, the companies will not allow to you to build those model if you don't understand that, because ultimately you're dealing, if you are working in finance, you're dealing with people's money, right? You have some responsibility, so you should understand that. And here, for marketing mix model, it will impact your revenue, right? So you can't simply uh, allow someone who doesn't understand what is going behind to build these models and take a decision on basis of that, right? And that's where you should learn about these things. uh, so there is an article uh, by HBR. Okay, so Karim is a professor at Harvard Business. He says that AI won't replace human, but human with AI will replace human without AI. Okay, there is a video on YouTube also. I highly recommend you to watch it. uh, I'm not asking you to learn code. Okay, if you are someone who is senior in the organization, at least you should understand these things, right? uh, so lot of we talked about open source libraries, right? There is a library called PyMC Marketing by PyMC Labs. This will help you to build this marketing mix model, then compute customer lifetime value also, right? So you can do that. Okay, so the typical regression model looks like this. Okay, so typically those will be multivariate. We will use single factor model here. Let's say y is your sales. Okay, and beta 0, which is your base sale. If you don't spend anything on your campaign, you will have, let's say, 200 crore sales, but let's say this is 10. The moment you are spending 10 crore, this is spend, okay, on marketing campaign, right? 10 crore, it will add 100 crore to your final sales, right? And that is very beautiful. So you can understand, if you do this, what kind of impact it will have on your revenue, right? And having that information beforehand is very useful, right? uh, Now we talked about finance related problem, marketing related problem. Let's talk about healthcare and how you can have uh, impact on society, right? Uh, so let's say you are working with uh, healthcare organization. They want to understand if tumor is malignant or benign. Benign means not cancerous. This is typical classification problem. We'll see how you can solve that. Okay, uh, then the second is that, let's say you're working with one of the top international hospital, and suppose there are 1,000 patients came to hospital. Now you want to understand from those how many has highest risk of hospitalization next week. You can run the model on historical data and take better decision. From that, let's say 50 patients has high risk, then you can relieve patient early who are uh, feeling better. Okay, and this is the article by McKinsey. They are talking about healthcare analytics. You should read it. Okay. uh, Google has built automated retinal disease assessment ARDA, which uses artificial intelligence to help healthcare worker to detect diabetic retinopathy. ARDA has screened over 200k patients in clinic around the world, right? 200k patients around the world, from urban cities in Europe to rural communities in India. There are not enough specialists in many parts of the world, and having AI powered screening system could help doctor to reach more patients. So this will help doctors a lot. Uh, and this is the executive team who is working with Google to build this system. Okay, you can have a look at that. I have shared source link also. Okay, now we will talk about how statistics is getting used in managerial decision making. uh, so this is a very beautiful research paper uh, by Altman, where uh, he built a model. It's called Altman Z-score model, which is used to predict the chances of business becoming bankrupt in next 2 years. Okay, so a lot of company used to use this. Okay, uh, he used something called linear discriminant analysis. We'll talk about that. And this was the regression model. These are the coefficients. You can see what is the meaning of those variables. This is from Wikipedia. Okay, use LDA. We will see this in ML. Okay, uh, this is course. This is training program by JP Morgan Chase on GitHub. You can have a look at it. They are showing how you can compute the Altman Z-score in Python. Okay, and it can be also used in managerial strategies and financial market. You should read this paper. Okay, we talked about econometrics modeling, right? We will see a few more problems. If you're having good hold on domain knowledge, then generative AI can help you to build this model. You don't have to like do everything yourselves, but at least have an understanding, because often it happens that model like the generative AI will give you something. If you're not able to understand, you will make decision basis on that, and that will be bad decision, right? If you have good hold on fundamentals, and then you can take a help of AI, right? So let's say you want to understand what are the effect of exchange rate on the trade flow, right? You can run the econometrics model and try to understand that. What is the impact of specific policy intervention on economic outcome, right? We talked about this. Then, does change in price affect the quantity demanded for particular product? So this is typical. So this will be first lecture in economics, right? Impact of price on the demand, right? But what you should do is that you should take a real life data, collect small sample data, and run the regression and see if that is the case. At what price point exactly the demand is decreasing, right? So you should do that. I'll show you how you can get those datas. Okay, um, if you are someone who is fresher, don't know how to apply these things in your domain, then what you can do is that there are open source libraries, companies like Microsoft building toolkit that combines state of arts machine learning techniques with econometrics for better economic decision making. um, so it's open source, it's on GitHub. It's called Alice automated learning and Intelligence for Causation and Economics by Microsoft Research. One of the top-notch researcher in industry are working on this problem, and you can have access to these things, right? There is one notebook I have shared. They are working on house price data. You can have a look at that. Okay. uh, so we talk about healthcare related problem, finance strategies, right? Now let's talk about how analytics is getting used in people analytics. Okay. So let's say you are the HR head and you want to predict the employee attrition, right? um, Predict whether the employee will leave company or not. Having access to predictive model where a manager could see the future effects of changing any of these factor would be very useful in strengthening retention, right? um, why people are leaving, if you are able to understand that, um, you can manage um, and make impactful decisions, right? So using people analytics you can uh, gain these insights, but you should run the models on historical data and make informed decisions. So a lot of companies, by the way, using these models, they typically see at what time employees are logging in. If they are coming late, then that is sign that they might leave, right? Not necessarily, but companies do build this model. They look at a lot of factors and then they uh, manage those resources, right? So this is one, right? Then there is a another problem, right? So let's say you want to make some impactful decision, right? uh, let's say on an average you figure out that from historical data, typical employee take 6 days off a year, right? um, and you are having 1,000 employees, so that is 6,000 days off, right? And it cost company around 10k if employees not there, so it is costing company 60 million, right? Or 6 crore, right? Now understanding that people do get sick, if you are able to save 1 day per employee by allowing remote work and creating more engaged workplace, that saving would be 10 million, right? Or 1 crore, right? You can save that by rolling out that policy. Being able to model out such scenarios can go a long way financially and culturally. So this is open source book, you can have access to that. There is a code also. Okay, if you are interested in people analytics, I would highly recommend you to buy this book. We talked a lot about how it is getting used. Now let's dwell deeper into theory part, and along that I'll share a lot of real world business problem. So data is key to modeling, we know that, right? uh, so in statistical analysis we have descriptive statistics and inferential statistics. When you look at data, you look at the distribution of data, mean, median, mode, if you have any outliers, so that is your descriptive statistics. And inferential statistics is when you make inference about population based on your sample, that is your inferential statistics. And this is the art part, you will improve your modeling skill with experience. Okay. So let's talk about example. Okay, let's say you're working with government and you want to know the unemployment rate. It is not possible to go to each and every person and conduct a survey. It is computationally heavy, expensive, time consuming, and that's why you take a sample and make a inference about population from that sample, right? uh, when I say it is computationally heavy, let's say you want to understand unemployment in India and you are going and asking each and every guy their employment status, you will have to deal with 1.4 billion data. which is first computationally heavy if you build model on that. Second, that is expensive because you will have to uh, employ a lot of people to do that survey. Third, that is time consuming, which is not practical. It will take years to come to that conclusion, and that's the reason we deal with sample, right? uh, Population is a group we are interested in studying. Sample is subset of population of our interest. uh, Parameter is a numerical quantity derived from population, which is almost always unknown. So you denote mean population, mean of, let's say, population by mu and sample by x bar. Then there are other measures also, like variance, size, standard deviation, right? uh, Whenever we build model on samples, right? How we derive that sample, what techniques do we have? We'll talk about few techniques, we'll see that in practice also. So we have random sampling. We can take random samples out of data, okay? Then we can do stratified sampling. In stratified sampling, what we do is that we create different strata from the uh, population, and then we take a proportion of that, and that is my sample, right? Then there is a cluster sampling. We create different cluster and take few of those cluster, right? Stratified sampling, let's say, in our case, unemployment rate, uh, each city represent each strata. Will have to go to each and every city and take same proportion and then analyze that, which will take a lot of time because surveyor has to go to each and every city. Rather than that, what we can do, we can classify, saying that tier 1, tier 2, tier 3 city in each state, and we can go to few cities within tier 1, tier 2 and tier 3, and then analyze, and then we can come to conclusion, right? So these were the few techniques. We'll see these in practice also. Now, to do that, we have open source libraries, and the tools which we'll use, we will discuss about that, okay? So we are going to use Python 3.10. okay, a lot of people debate about this language, but what I would say, we should be flexible enough for a lot of things. R is good for analyzing data, building complex model. Python is really good, okay? So we should be flexible. What we want to do is that solve our business problem and not to uh, like stick to tool, right? But we should be good at few of them, and other one we can pick along the way, okay? Whenever we will use Python, mostly we will use Jupyter Notebook. If you're not able to install that by any reason, you can use Google Colab, that is for free, okay? We'll use libraries like pandas, NumPy, stats model. So pandas is for data manipulation, NumPy is for numerical operation, stats model is for building statistical model, SciPy is for optimization. There is a library called CVXPy also, we'll look at that. Scikit-learn is for machine learning model, Matplotlib for visualization. We'll use Seaborn, then Cufflinks, Plotly. There are a lot of libraries for visualization. We'll look at that. So little detail about pandas, which is heavily used in data science. So pandas development started at Applied Quantitative Research, which is hedge fund, and that was open source by the end of 2009. It's now actively supported by a global community of contributor, and that library is open source. This is very beautiful, right? Now let's look at the data, okay? Let's say we get a data and we want to analyze what kind of data we have. So in data type, we have main, categorical and numerical data. So let's say you are analyzing industry data, right? And you have industry classification, that will be nominal, right? Because let's say there is a healthcare, banking. So these are the different industry. Sequence doesn't matter, right? So this is nominal, right? And in ordinal, sequence does matter. So in, let's say you are analyzing portfolio quality, order will matter, right? Good, neutral, or bad. But in nominal, even if you say banking, after that healthcare, order doesn't matter. uh, then in nominal, there is a special case of nominal, which is binary. uh, Binary means having only two category, default or non-default, right? Order doesn't matter. uh, then in numerical, we have discrete and continuous. So number of credit card transaction can't be continuous, right? It will be discrete, 1 2 3 4. We can't say that 1.5 transactions, right? Continuous, let's say stock prices or returns, that will be continuous, right? Rainfall measurement, that will be continuous, right? So these are the data types, and this is very important while building model. Okay, we will see now how we can take this into consideration while building the models. Okay, APIs are the future. Okay, what is API? Application programming interface. Act as an interface that allows proper communication between two programs. Okay, Google Map is one of the best example. A lot of companies use Google Maps API, and it allows them to develop product and integrate Google Map location based services into their application, right? um, Companies like Blinkit, Zomato uses these APIs, right? uh, by different vendors. So many entrepreneurs will build new and successful technology business by combining third parties API in new and interesting way, right? And that's the reason a lot of companies do open source these. Okay, so there is a beautiful library, it's called scikit-learn. We will use that for model building. So what kind of model we can build? Classification model, regression model, then we can do clustering. This is typically will be used. So these models are used by, let's say, Netflix, right? They cluster those movies. Let's say there are 10 movies, and next time if someone is watching 2 or 3 movies from this basket, then they will recommend 5 6 movies, right? uh, Classification, default or not default. Regression, you want to predict the rainfall, you can build regression model, right? And we'll use this library for that. You can see the code implementation, and this is the link of the repository, how they are implementing this, and you can also contribute to the issues, right? And first we'll go through this whole course. Once you have fair understanding about everything, then you should try to contribute to open source. Yeah, so now let's start with how we can use these API. So what we want to do when we look at data, we want to pre-process that. So in scikit-learn there is a pre-processing data, right? And you can go through these documents and see this is the link for that. Okay, so let's say you have ordinal data where order does matter, but machine learning model will not understand good, bad, neutral, right? It will not understand the sequence. So what you do is that you give order. You can say that good, neutral, bad, or bad, neutral, good. Neutral should be in between, right? Because that's the sequence. And then what we are doing, we are encoding that, and then for good it is encoding 2, bad it is 0, and neutral is in between, right? And this is how, and then machine will understand these numbers, right? This is how we'll use these API. Then there is a label encoding. So let's say we have the stocks, then their sector, and we want to do encoding for sector and industry, right? So as you can see here, wherever there is a internet service, it is saying 5, right? and wherever there is a sector technology, it's saying 3, right? 0, it's consumer, right? Then banks, for banks it's 1, right? So this is how encoding works. Okay, then there is a one hot encoding. Okay, so when we build model, with respect to model, these techniques will change, right? For classification model, typically will give 0 or 1 because it will help logistic regression to say it will default or not, and we'll talk about that later. But these are the data pre-processing one should do before building model. Okay, so what we are saying is that for if property is buy to let then 1, otherwise 0, buy to let then otherwise 0. What happens is that in practice, if something goes wrong in market, right, and a lot of people will started defaulting, first they will repay their loan where they are staying, right, which is owner occupied, right, and second they'll make payment for buy to let one homes, right? So yeah, this is like typical credit risk models. We'll talk about that. We already talk about open source software, how they can help us. um, it is estimated that around 3.5 times it would have taken if there is no open source libraries, right? Roughly it's 8.8 trillions, uh, which is like open source code available there, right? uh, then little bit about pandas. We already talked about it. Panda started in 2008, open source in 2009, developed in AQR. Now you can see these timelines, right? And this is the documentation. This is the documentation page, right? You can go here, click here and read what all options you have in pandas. AQR is hedge fund, it's applied quantitative research. Cliff Asnis, David and John are the founders, right? All of them. I know John, I know Cliff and David is billionaire. Okay, so talk about pandas. Okay, so in API's reference, so this is the most used pandas API. So that is data frame, right? Whenever we get cross sectional data, that is called data frame in pandas. Okay, and what we can do with that, we can look at info, values, then shape, size of that data, then we can look at mean, max, right? Whatever statistics we'll talk about, descriptive statistics, standard deviation, we can compute that using API. So let's say this is the data we have: company name, sector name, revenue, net income, total assets, market cap, and P ratio, right? And I want to analyze this. Okay, so what I'll do, I'll use pandas library, I'll use describe. Okay, so what describe does is that it gives you summarize a version of data. It will give you central tendency, shape of data, right? So I'm having 13 records. Mean of revenue is 168 billion, 165 billion is standard deviation, 23 billion is minimum revenue which firm has. 25% of them are like 70 billion, then 85, and then 182, and max revenue is, this is percentile data, 75th percentile. Then max is around 560 billion, right? Let's say you're analyzing this column. You're looking at on an average PU of company, which is saying that 93, right? But this is skewed because of this one company, which is, if you go back and look into data, we will find out that tesla tesla is having highest PE, and because of that your data is skewed. Okay, we'll also look at how to deal with these measures and how to build model around that. But this is giving you sense, whatever descriptive statistics we can do that with single command, and which is very powerful. Okay, uh, then what kind of data type we have structured data and unstructured data. We'll also talk about how to analyze unstructured data. Okay, so structured data is organized data, quantitative data, example like financial statement. Unstructured is diverse structured, qualitative, example text document, right? So this is unstructured data. A lot of funds are using unstructured data to make decisions. We'll also discuss that, how we can do that. It's called natural language processing, NLP. Then let's say you are having huge customer base and you want to see how many of them are like having uh, excellent credit score, right? How many of the default uh, customers are having good score, right? So this is the contingencies table, which is like it will give you data in a structured manner, whatever data you have. So this is kind of summary version of your data, right? Now we'll talk about descriptive statistics. So what kind of measures we have a measure of location, right? Measure of central tendency. What we can look at is that we can look at mean, median, mode. Then we have trimmed mean, weighted mean, Wins rise mean. We'll talk about which one to use when, right? Then we have measure of other location, quartiles, quantiles, decile, interquartile range. We'll see how IQR will help us to identify the outliers and how we can solve business problems using outliers, right? Measure of central tendency. Okay, mean. So what is mean? Mean is basically sum of all the records which we have and the count of that record. Let's say you have revenue is 3 billion, 2 billion, 2 billion, then 5 billion. There are 4 companies, right? On an average your company is making 3 billion, right? You should use mean when you do not have outlier in data set. So just to give you example, okay, let's say you're working with Tesla and you are in meeting room with Elon Musk. One can say that average net worth of person in this room is more than a billion, but that is not accurate measure. If data has outlier, in this case which is Elon, you should not use mean because it is sensitive to outlier. You should use median, right? It provides the robust measure of central location when data has outlier or skewed, right? Now how do you compute median? If you have let's say even number of record, you can take two values in middle and divide that by 2, you get that. And if you have 3 numbers, simply the middle value is your median, right? Then you have mode is most frequent number. Okay, in this case it's 2 most frequent in this series. So mode is very helpful. Let's say you are working with Amazon and there was some sale, let's say, and you want to understand most frequently sold item. So at that time you can use mode, right? And it can happen that there are 2 most frequent sold item and the count is same. So at that time you call it is bimodal. If there is only one mode, then it's unimodal. Okay, so let's look at weighted mean. This is a very helpful measure. You are looking at 2 variables in one go. It's kind of bivariate analysis. Whenever you get data, you do EDA, exploratory data analysis. You explore data. So we can look at one variable in silo, that is univariate analysis, and then two variable in conjunction, that is bivariate analysis, right? um, so let's say you are analyzing bond deal, right? And you want to look at weighted average maturity of bond deal. So that is your duration, right? Duration, typically it's a measure of risk, because if you are investing and which is taking time you to repay, in that period of time something can go wrong, and that is the risk you are bearing, right? And let's say you are holding three deals, right? Let's say deal 1, deal 2, and deal 3. This is worth 6 billion deal, this is 3 billion deal, 1 billion deal, this is like total is 10 billion. This is my 60%, this is 30% of total, this is 10%, right? Then my duration, loan size, right? 6 billion, 3 billion, and 1 billion. Duration for this, let's say it's 3 year. For this it's 5 year. For this bond duration is 5 year, and for this let's say 15 year, right? So you multiply these numbers and you get weighted mean, right? uh, Weighted duration, sorry. So don't have to do manual calculation, just get a sense how this can be helpful, right? For the whole portfolio you are getting weighted average duration, you can't simply take a mean of duration, right? Because the ticket size is changing, right? uh, so for this what you can simply do is that in numpy, np dot average, and you can pass bond weight, which is this 60%, 30%, 10%, and then maturity, right? And you will get this weighted average maturity. Then let's say you are looking at the mean data, um, p ratio, and you're having some outlier, right? So let's say and you don't want that weird mean which was there in earlier slide. What we'll do, we'll use stream mean. It will cut the like 10% values and it will compute the mean. In that, Tesla will be gone and you will get accurate PE ratio of other firms on an average, right? uh, so this is the example of house price. Let's say one house is 200 years old, and others are like 5 year, 10 year, and you want to analyze that. Let's say you are having thousands of uh, data points, you can use that. Then there is a Winserais mean. What Winserais mean is do that the top 10% and lowest 10% are replaced with the 10 percentile data, right? And then it will compute the mean, so it is robust to outliers, right? So these are the different measures which we can use in descriptive statistics, and these are the APIs. I have shared the code, you can try that on your own.